So what we're going to do here is we're going to update your NinoTNC, which is currently running firmware version 3.24, which we got out of, I logged into your, I can bring up your local host. I can bring up your software because I forwarded this. This is your TNC software running on through the same secure shell connection. And if I remember the password, don't save that. So we logged into here, and what we did is I did listen one, and then I got you to click the firmware button, the test packet button, and it spat out the results on this screen. And the first thing that it came out of that was the firmware version that it's currently running, which is 3.24. So that the first 3 number is kind of a hardware version. You only ever want to load version 3s of firmware onto this TNC. Having done that, we then want to go to the Nino website. This is Flash TNC on GitHub, and if you just search for Flash TNC in GitHub, you'll come up with this. And we're going to download all of this in one easy step. Going over to code, this gives us a URL which we can copy with this button. Boop. And then we go into the TNC. Now, if you go into, are you logged into your TNC? Logged in. Okay. That's a shame. We could use screen so you'd be able to see as I type along, and you'd be able to type in as well, but we'll do what we can with the screen share. I'm logged into your TNC. I'm in the home directory, which you can see with the little tilde symbol where it says Pi at Raspberry Pi. That tilde means home directory. And I'm just going to clone that URL that I copied out of this space on the GitHub. Sorry, I've missed a part of that command already. How excellent will this documentary be? Git clone copies all of that down. So we hit that, clones all that down, and what this will do is it'll create a directory called Flash TNC, which we can see right there in blue and black, which is probably quite difficult to read. So what you would normally do if you wanted to redo the updates, you would go into Flash TNC and you would do git pull, because it remembers where the software came from, and it will go and get the latest versions of everything from the GitHub website. All you need to do, go to that directory, git pull, and it's telling us we're already up to date because we just got it a few minutes ago. That's it, done. That's the software on the Pi. Now we need to put it on the TNC. The important step, so if we zip down this is quite a long list of instructions, which can seem overwhelming. We're going to skip a bunch of it because the instructions for Windows don't matter, the instructions for Mac don't matter, the different architectures of Windows, who cares? Instructions for Debian Linux, that's where we are with the Raspberry Pi. It's a variant of Debian. We've already seen, I've already been in here and checked, PySerial is already installed, which is the program for Python talking to the TNC, which is dead handy. This is the git clone step that we just did. Git was obviously already installed. We've cloned the software down to this computer. We want to find out which socket your TNC is plugged into. So if we type dmessage, a vertical pipe grep tty, this is a bunch of boot messages. Every time you plug in a piece of hardware or anything like that, it's going to dump some information here. And there's various layers of drivers built on drivers. You know, this is a USB device, so it identifies it that, and then it identifies it as a TNC, and then as a serial device, and so on. But right at the bottom, we have TTY ACM0 USB ACM device. This is the actual file on the Pi that represents the NinoTNC. Next step, critical precautions to prevent bricking your PIC, is turn off everything else that's going to be talking to it, which in our world is the BPQ software. So we will go and find the BPQ software. You do that with systemctl vertical pipe grep bpq. I can't remember what it's properly called, but it will have bpq in there somewhere. We'll stretch that out because it does all return on one line. You've got the service loaded, active, running. That means your service is there, everybody's happy, it's running, and we need to stop it. So now we need to do this as root. So we sudo systemctl stop. Of course, as soon as the recording starts, I lose the ability to type. Stop lin bpq service, and this is just directly copied from the start of this previous results line. That will take a few seconds, and this is a control that's expecting this sort of command. And if we pop back to here, hey, the connection was reset. And if I try and connect now, resend, connection was reset. It's not having any of it. You would potentially get different errors. I'm having, because I'm going through secure shell, I'm getting different errors from what you'd get locally, but that's saying that the service is stopped. And we can confirm that with if we do the same systemctl grep bpq, it's gone. Yes. So we should now be in a position to run the update. We've done the critical precautions, and here's the command. So they've got a little bit of bump in square brackets, which means fill in the blanks, please. So we do python 3 flash tnc.py, and I just typed in the first couple of letters and pressed tab to autocomplete there, because, you know, typing sore wrists is the miner's lung for programmers. We just want the most recent hex file, so we've got version 3.32 there, and we've got version 3.33 there, and then these two are the version 4s for the newer processors. Yeah, but this one matches, the V3 matches the 3 point from the firmware thing. Paste that in, and then the device is /dev/tty acm0 acm0 oh tty, yeah, there we go, acm0. And again, tab complete is a handy thing, because if it doesn't tab complete, you've probably typed something wrong. That's it. This is the whole of the list. So this should, if everything is in place, go away, do all the work, reboot the TNC, and we're happy. Or it will complain that we've done something wrong, or there's a module missing. The error correction and detection is quite good. Boop-de-boop. Flushing serial buffer, so it's going to cram a lot of data through there just in case BPQ had left anything in the buffer. It wants to be the only thing that's going to the TNC. Oh, could you turn off your radio, please? Okay, so you see errors happened. We made a mistake in the process, and it detected that there was a problem and complained at us and made good suggestions. Just press the up arrow to get the previous command you typed. Hit it again. That's looking a lot more likely. Okay, and this is it. This will take a few minutes. And you'll see that it's got a start time on it. It'll give you an end time as well, and it'll give you a process every 1,000 lines of firmware that it's written to the TNC.
So, with the firmware update, I believe it changes some of the commands slightly.
Everything that you have been using should be identical. This brings a extra mode 4800 IL2P with CRC checks, so an extra robust protocol versus bad packets. And this most recent version comes with, if you had tested, if you'd clicked the packet button a few times or held it down, then it would have just cycled sending test packets until you told it to stop, until you clicked it again. And somebody did that on HF with no call sign for about 4 hours. So the very next version of the firmware, which we're installing now, I think it counts up to 100, which is about 2 minutes worth of data, and then forces a reset on the TNC. So even if things go terribly wrong, there's a limited amount of damage that can be done.
So this is like actively supported, up-to-date firmware that's
Yes, the
real life situations.
the designer slash one of the team is a member of the OARC Discord. There is a NinoTNC help channel, and if you go there and ask questions about the hardware, it's very likely he will come back to you. And he was part of the conversation with what do we do about this? Ofcom are going to go mental. What's an appropriate response? And that's where, a few days later we came back with this firmware won't indefinitely send signals no matter what you do to it. So yeah, pretty actively supported, which is awesome.
It's very good, isn't it?
Any questions about what I've done? I realise I talk fast, but did that broadly make sense? The later firmwares as well are brick resistant as well. It might not work if an update fails, but it won't break so hard that you can't push the update again. So you're not having to, desolder chips and stick them in a firmware writer. Okay, that is the uptime. So that start time was 2:48 and the finish time was 2:51. So that's about 3 minutes, just shy of. It's giving you a line count. I don't know how we verify that, but it seems to say that the firmware update was successful. So what we can do is start that. So this restarts the service, and then we can do the same sort of grep bpq, loaded active running, pop over to our terminal page. And hey, look at that, we're back in already. So radio needs turned back on. What I will do is I'll do listen 1 here. If you turn the radio back on and poke the test packet, we'll get the firmware will come out on this screen at the same time.
There we go. Radio on. Test button pressed.
Brilliant. So I'm just on my own terminal here connecting to your node, and that seems to be working fine, so that's good. And when you hit, of course I turned up and did lots of listening. When you hit the test packet, we got this line out, which has got firmware v3.33. So everything's happy. You're on the latest version of the software.